Hi, I'm Bruce, and welcome to my Baptronics Colorado Mountain Lab. And today we're going to look at a B&K Precision 1856 1.3 gigahertz counter. This counter is in remarkably good shape. Basically looks brand new. Top, bottom, sides. Good rubber feet. Handles in good shape. And the rear here. There's a totalize start stop button in the back, or input in the back, and then you have line voltage select. This is serial number 222-00085. Right now, I have this unit connected up to my standard, and I'm reading 10 megahertz coming out of that standard up on the top, the silver front, with that little tube sticking out of it. I'm confirming the frequency on my PM6676 Philips. And we see that we are getting a good 10 megahertz signal to better than a hertz. If we go to a 10-second average, give the thing a few moments to respond, we should see the 1 shift off to the left, and we'll see whatever our remainder is. So we are zeros all the way down. So we're better than 0.1 hertz zeroed in right now. And my temperature in the room here is about 68 degrees. It's got a very good TCXO time base in it. And as you can see, very bright, large 3/4 inch, maybe even higher than 3/4. I should measure that, but the LEDs are very bright. No mistaking it. This is a 1.3 gigahertz counter. Right now we're on channel A. It's a 1 megohm input, so it's sensitive. It'll go 5 hertz to 100 megahertz on channel A and 125 volts RMS maximum. You have a your times 1 or times 10 via this push button as far as attenuation, and then you've got a low pass frequency button, and we are right now reading 10 megahertz in kilohertz. We could go to megahertz. And then channel B, if we were connected, but we're not, you've got a period indicator here. And then totalizing. A check of all of the LEDs and the circuitry. And then on this side, we change our range. And that goes to the 10-second average. Here we are at a 100th of a second, a 10th of a second, 1 second, and then 10 seconds. Channel B will read up to a gigahertz. We're going to run this thing through a couple of frequency checks and just to prove that it's working. So bear with me. Okay, well, we're on channel A, and we are right now pumping in 100 megahertz frequency coming in from that PTS 500. And as we see, we are 100 megahertz, give or take a count. Let's take her down. Here's 50. And let's go to 20. No problem. That's 1 megahertz. Sorry. And we'll go 500 kilohertz. Okay, we're connected up now to this Hewlett-Packard 3320B frequency synthesizer. It's good for the frequencies less than 5 megahertz, and we're right now running at about 500 kilohertz. And we see that the counter is giving us 500, so no problem there. Let's take her down a decade. This is 50 kilohertz, and we got a response of 50, no problem. Let's try 5 kilohertz. And there's 5. Okay, here's 500. 50. And then finally 5. So we've traversed 5 hertz to 100 megahertz on channel A, no problem. Let's check out channel B. Okay, well, we're connected now to the PTS 500. We are coming in on channel B. We've switched to channel B utilizing the function button here. We've shifted over and you see the light for channel B lit. And we've input 80 megahertz and we see that we have 80 megahertz on the counter, no problem. That 80 megahertz represents the low end of channel B as far as the stated frequency of 80 megahertz to 1.3 gigahertz that's right on the front panel. So let's go ahead and take her up to the max of the PTS, which would be about 499. All right. And let's see what we... And there we go, 500 megahertz. That's the limit of my PTS 500. So we're going to have to take it now from the PTS. We'll go to this Hewlett-Packard 8640B. And we're going to go ahead and install the doubler. I've got an external doubler on this. And we've got ourselves dialed in so that we've doubled the frequency on the counter inside of the HP. So it knows I'm using a doubler and it's telling me double the frequency. Okay, well, we've got the 8640B cranked all the way up. We're getting about 1.09964 gigahertz coming out of the doubler. And we're feeding it into channel B and we see 1.0996363. So we got a couple extra decimal points of accuracy, but it reads the same. So we are reading over a gigahertz with this unit, about 1.1 at this point. We should have 200 megahertz more to go. Unfortunately, I have nothing that generates that signal. Let's examine the period here. We'll take a look at it in a moment here. Okay, well, once again, I'm connected to the Hewlett-Packard 3320B. I'm generating a 5 hertz signal, and I'm reading 5 hertz on the meter, which is all good. But I'd like to take a look at the period. Period kind of comes in on the low frequencies, very handy. Okay, well, we're connected to the Hewlett-Packard 3320, generating a 5 hertz signal. We've got ourselves in period mode, and we are right now range-wise on the 0.1 second range. We're getting counts bouncing between 199,999 and about 200,000. So if we choose the 200,000, it's 200,000 microseconds, which would be 0.2 seconds. 1 over 0.2 is 5. So we are running at 5 hertz. And I've got several digits of resolution out of this to even give me a fraction of a hertz. And I can change my my time base range, we could kick ourselves up to the 0.01 second time base range, and we flicker much more frequently, but several times a second here. But we're right at 200,000. That's what we wanted. Let's take the frequency up to 50 hertz. 50 hertz, we drop to 20,000. 500 hertz, 2,000. We can kick up our range a little bit, give ourselves a little bit more resolution. A little bit more resolution. Okay, let's. This was 500 hertz. Let's go to 5,000. And we can see 200, a count of 200 microseconds at 5,000 hertz. At 50,000, we see 20,000. Excuse me, 20 microseconds. 20.000. This is 500 kilohertz, and we see 2 microseconds, which would, in my head, seem right. This is 1 million hertz, and we get 1 microsecond, which is right. So the period function is working just great. Let's put ourselves in totalize, and we see that we're off and running, totaling the count. In the back, there is an input that allows you to input a start-stop voltage on there, and you can use it to control the totalizer triggered by some outside event. That's good to know too. Let's turn this thing down. It's 100 hertz. Let's go ahead and reset the thing. Start a new count. The totalizing function working good too. There's a check function on here that checks the internal circuitry, and it shows you 10 million on the front panel. Gives you all the display digits, and if you get that, then you know that you're working well on the inside. So it's a little self-check. So okay, thank you for listening. I will provide a manual on a disc. It is for the BK Precision 1856C. The C is identical looking, it has all the same function buttons, works the same, so the manual can be used by the user in the same method. The only difference is that the C goes up to 2.4 gigahertz, and this goes up to 1.3. I would like to give you the right manual, but unfortunately I couldn't find it. The closest I got was the C. But you will have a manual with it, and I'll even throw in a set of test leads to start with. So thank you for listening, and happy bidding, and we'll see you next time.